Okay, so we've done some of these. So we're on practice test 2, problem number 2. And we are going to maximize the volume of the box. Okay, so the paper this time is 10 by 16. So what's our volume? What's our equation for volume? Volume equals? Well, 20 length times width times height, but what is it going to be specific to this problem where we have cut out corners? 10 minus 2x, 16 minus 2x, x. The equation for the volume is always dimension minus 2x, dimension minus 2x times x. That's it. Now what about the domain of the problem?
0 is less than x is less than 5.
Bingo! X is always going to be between 0 and something. X has to be positive. It's a corner of the box. So how did he get pi? Half the smaller dimension. So whatever the smallest dimension is, in this case it's 10, this is going to be half of it. Okay? So anybody that misses this just isn't paying attention, because every single problem is set up the same way. What is the formula for the volume? Dimension minus 2x, dimension minus 2x, x. Every time. And what is the domain every time? X is between 0 and half the smaller. Period. So then we get our calculator out. And this goes in for the equation, and this goes in for the window. Oops. And we get our picture. And in terms of setting up your window, this 0 is always x min. This number is always x max. Y min, because y is the volume, y min is always 0. And what's y max? A guess? Yeah, I mean, you guess. And what do we need to see? We need to see the top of the hill when we hit graph. So as long as you see something that looks like that, you are good. And then some of you just start using your arrow buttons, and that isn't what you do. If you want the maximum, and I'm going to be picky, you shouldn't be off at all if you're doing it right. You got to press second calc, right? And then move the cursor and set the left bound over here. Move the cursor, set the right bound over here. Right? And then move it in here and hit enter, and it should give you the maximum. And so if I do that, second calc, maximum, left bound, right bound. My maximum came out, oh gosh, it came out to be 2 and 144. It came out to be exactly. That was luck. So, now I have to answer the question. The calculator says x equals 2 and y equals 144. So, what does the 2 stand for? In terms of the problem, what is the 2? The size of the corners. Yeah. So if the question was, how big a corner should you cut out? You would say 2-inch squares, right?
Yeah.
But if the question says, what is the maximum volume? Then you're going to say 144 cubic inches. X is the size of the corners, Y is the actual volume. That's the way you set it up. X was the corners, Y was the volume. Okay? If you're still struggling with that, you need to get in here, because just do it, it's easy, you just need to get sorted out how to do it. Next one, we are gonna go to the restaurant, we're gonna pay $16.55 for our food. And then we're gonna pay a 7% tax. Is tax an add-on or a deduction? An add-on, that's important. And then you're gonna be a 20% tip. Is that an add-on or a deduction? An add-on. So this one has two add-ons. What do I multiply by if I'm adding on 7%? 1.07. What do I multiply by if I'm adding on 20%? 1.20. I just type it in on my calculator, round it off to the nearest cent. And I got $21.25. Tell me what you got? That one, again, we are all gonna get the same answer. So if you're off by a penny, you're wrong, because we can't be off. We're all gonna get the same answer if we do it without any round up there. All right, we're gonna do it like the restaurant does. All right, how much? Okay, this is my mixture problem. So my formula, if you want to call it that, for a mixture problem is amount times percent plus amount times percent equals amount times percent. 6 things in the problem, 3 amounts and 3 percentages. These two add up to that one. How much 28%, so there's 0.28, should be mixed with 20 cups of 10%, so there's 0.10, to get Kool-Aid that is 22%. So those are just my percentages, just copied down. Now the only other number in the problem is the 20 cups. And that 20 goes with the 10, right? What are you doing? I know, you're not doing what you're supposed to be doing. Put that away. What is that? There is nothing in your day that's more important than what we are doing right now, my friend. All right, so what goes in those other 2 blanks?
X.
Yeah, how much? The question literally says how much. That's X. I don't know. And then, what am I doing with these 2? I'm adding them to get that, right? So this is going to be X plus 20 or 20 plus X. I'm adding these 2 together to get that one. Then I'll use my calculator to help me with the arithmetic. Oh my gosh, I think this one comes out evenly too. Don't forget to put a unit on it, it's cups. Now, I did that without my calculator. I hope I did it right. Anybody get 40? Are we making progress? So this is a distribute. Don't forget, that's a distribute there. Combine my X's, combine my numbers, and divide it. 40? right, last year tuition in a local school was 11.8. This year it's 12.2. Find the percent of increase. Easy. How do we find the percent of increase? Find the difference. What's the difference in them? 400. And divide it by the original, which is 11.8. Type it in, make it a percentage, and that is your answer. So 400 divided by 11.8 gives me decimally 0.033898, but percentage-wise, that would be 3. You could say 4 or 3.9, depending on what the rounding directions are. 3.4 would be to the nearest tenth. 3.39 would be to the nearest hundredth. So just depending on what the rounding instructions are on the test. And that is an increase. So it went up 3.39 or 3.4%. Okay, now we've got problems that we've already done today. So I'm sorry if this is boring.
I can't deal.
We are all going to try to pass this test, so we can pass. That would be awesome. So let's look at the picture that's drawn. And while I'm recopying it, what do you suppose you could be doing? Labeling them. I didn't do a good job. That's one hash mark. These are down. They're down on me. Okay, so you're going to label all those. And then I'm going to skip down and do D first. I'm going to sketch it, the inverse. So what do I do to sketch the inverse? I'm doing problem D first. I just switch them. So I'll plot 0, -2. I'll plot 2, -1. And 0, 0. So there's my first piece. Then 1, 1 doesn't change. 0, 2. -1, 3. -1, 4, and 0, 5. So this was the original, and this is the inverse. And I graphed the inverse by simply reversing the ordered pairs.
Will there ever be one of these where the inverse is a function?
Oh no, it could be a function. Now, not if it's got a triangle or something in it, but think about the reciprocal function. If the original shape was this, yeah, the inverse is going to be, actually, it's its own inverse. If you reversed all those points, you get the same thing. So it's its own inverse. And they're both functions. This, a linear function, if you reverse those ordered pairs, it would be another line.
But like those.
You can't have a triangle, no, because you got repeated y's, and the repeated y's are going to become repeated x's when you flip them. All right, so that's D. All right, let's go back to A. Is this a function?
Yes.
The original is a function. Why? It passes the vertical line test. If you say yes, guess what? You don't get credit because you haven't answered the question. You have to give an explanation. Is this a function?
No.
Nope.
No.
This is not a function because it does not pass the vertical line test. So is the original problem 1-to-1? No, because to be 1-to-1, the function must be an inverse, f must be an inverse, he's saying inverse, f must be a function, and f inverse must be a function. They both have to be functions for them to be one-to-one. Notice how I didn't answer the questions in order because it helped me to have this picture. So I did that picture first. Fine, do the picture first if that helps you. All right, so now we've got these ones where we have to find the inverse. All right, so this is problem 7. I am finding the inverse. All right, so I'm going to switch my variables. Right? And then what? Bring this over here. And distribute. That's important. Make sure you're distributing there. This is a quantity. Now what?
Move the y's to one side.
Move the y's to one side, so 2xy minus 3y equals negative x minus 8. Just flip-flop these two.
Get rid of the y.
Can't get rid of the y, but we can factor it out. So 2x minus 3. And then we will divide. So negative x minus 8 over 2x minus 3. And then function notation.
And the order on the top does not matter.
Nope. As long as they're both negative. Then you got the same problem, but it's easier. It's not as complicated, but it is exactly the same problem. So you're going to have an easy one and a hard one on your test. Don't forget here, though, you got to switch the variables before you get started. Before you get started, switch your variables, and then jump in. So 4x equals 8y minus 3. You with me?
Yeah.
And then 4x plus 3 equals 8y, and y equals 4x plus 3 over 8. So I just switched my variables, brought the 4, got y by itself then. Switch the variables and get y by itself. So I have to bring the 4 over, add the 3, divide by 8, and then write my answer in my appropriate notation. Number 9. Find xy if t is for t equal negative 2. All right, this is, I'm just finding the ordered pair. So what is the x going to be? Negative 3. How are we doing that? Plugging it in. And then what is the y going to be? 4. Plug it in. That's all there is to it. That's the answer. Number 10, we need a direct algebraic relationship. What does that mean I'm going to do? What do I need to do? Get t by itself, and it'd probably be easier to do it here. You can do it either place. It really doesn't matter, but it'd be easier here. This says t equals 2y. I just times both sides by 2. And if t is 2y, then x equals 4 minus 2 times 2y. So x equals 4 minus 4y. Now, the real mathematicians are gonna wanna see that written like this, because that's considered standard form. But as long as you can get one equation with no t's, and you've done all the obvious simplification, I'll be fine. This is good enough right here. This is better. And then the last one. Now, I think you can see the axes a little bit better in this picture, so I don't have to redraw it. I need you to tell me what happened. In getting from figure 1 to figure 2, what happened? That's just in words, what happened? I think it's upside down. Would you agree?
The height got multiplied.
It looks like it's, let's see, 1, 2, 3, 4, 5, 6, it's twice as tall. What else? One more thing happened. It went down too. Alright, so now we have to write an equation that does all that. Okay? So what flips you upside down? A negative where? Out in front. There's a negative out there. What makes you twice as tall? A 2 where? In front of the x. So there's a negative 2 out here. What takes you down to? A negative 2 on the end? So if you graph that equation, you would get figure 2. Alright, so tomorrow we will do practice test 3.